So we spent a lot of time talking about speciation. Now let's talk about what's called systematics, taxonomy, and phylogenies. Here's the big difference between systematics and taxonomy, and it's taken me a long time to figure it out. Taxonomy is how you classify organisms. Yeah, wait, I take it back, I just screwed it up. Taxonomy is basically naming organisms versus systematics, which is grouping organisms. Taxonomy is the science of naming and classifying things that are currently extant. You've probably seen that hierarchy. At the very top, oh, by the way, so in the past, I'm sure you've had to memorize the whole like kingdom, phylum, class, order, family, genus, species. I'm not going to make you do that. That's just a waste of brain space. What I want you to understand is the idea that some groups are a higher tier than others. The kingdom, for instance, encompasses a larger group than the phylum. The phylum is a specialized group within the kingdom. The class is a specialized group within the phylum, and so on. You've got domains. This is the new way. Domains, and there are 3 domains. Underneath the domains, you'll have supergroups. Within the supergroups, you have kingdoms, then phylums, class, orders, families, genus, so the general group, and then finally the very, very, very specific that only names a single species. These groups are called taxons. Domain, kingdom, class, order, and so on. And they have that nested hierarchy. All organisms can be divided into 3 of the domains: bacteria, eukaryota, archaea. Bacteria and archaea are prokaryotic. Eukaryota is eukaryotic. In domain bacteria, you've got a lot of different examples. Go figure, they encompass the bacteria. They're much, much smaller than we can see with the naked eye. They're difficult to see even with the microscopes we have in class. Domain bacteria is prokaryotic. That means that it does not have a nucleus. You got domain archaea, which are filled with archaeans, also prokaryotic. These guys tend to live in extreme environments. We're going to get at differences very shortly, within a few lectures, of between bacteria and archaeans. But it's going to come down to a lot of the characteristics of the cell membrane. So they live in extreme environments. Lots of differences between bacteria and archaeans. I'm not going to ask you to know them for now. Eventually, I will get into all of the differences between bacteria and archaeans. It's going to be the most boring lecture you've ever seen. Domain eukaryota. Now we're getting to the stuff that you can see, you can touch, all the stuff that you wanted to deal with when you came into biology. Anything that's multicellular is going to be domain eukaryota. Anything that has a nucleus. Within the domains, you have supergroups. Excavata, the land plants, alveolata, Straminapilla, Rhizaria, Amoebozoa, Pisciconta. These are the supergroups that are found within the eukaryota domain. Now, in order to classify all these, again, taxonomy is really, really interested in naming conventions. The standard practice for naming conventions includes the genus name, the general, and the species name, the specific. This is Limulus polyphemus. It is the horseshoe crab. That's its common name, but Limulus polyphemus is its genus name and species name. This binomial nomenclature was proposed by Carolus Linnaeus, and we've just gone with it since. Now, there's a few issues I'm going to ask you eventually to name an organism, and you can name it whatever you want, but the big thing is genus names are always treated as nouns. The names usually have Greek or Latin roots, and each name typically describes something about the organism. So here are some fun names. The giant panda, the common name, is Oloropoda melaneluca, which means black and white catfoot. The polar bear, where does the polar bear live? Right, up at the pole. It primarily spends its time in water, so it's called Ursus maritimus, or the maritime bear, the water bear. Canis rujus, the red wolf, because it's literally a red dog. Sometimes they get a little bit weird because we start putting people's names on them. Linnea borealis is the northern Linnaeus. Yep. And good one here. We've got Fucensius brasiliensis. This does not have a common name because not many people talk about the Brazilian sea snail. You're not like out at a bar talking about Brazilian sea snails. But not everyone follows those rules. Some of my favorite species names, colon rectum. It's a type of bacteria. This one was named because it was it's the aggravation, and it was named because it was so hard to find the organism. The ahaha, I just like the way they did that one. Capiloni harrisonfortii. Sometimes scientists name things just to get attention from somebody that they're interested in getting their attention from. In this case, they wanted Harrison Ford's attention. Did it work? I have no idea. I do know this one got recognized. Agathidium bushii, Agathidium cheneyi, Agathidium rumsfeldii. These were all named after members of the second Bush administration. Yeah, second Bush administration. And they got recognized. And I still, to this day, don't know if they were insulting them or not, because these are all slime molds. And I was like, now it's an honor to have something named after you, but it's a slime. So I didn't know what they were going with that. So this is a time thing. Carmen Electra was think of a pinup. She was like the one that everybody wanted back in the 80s, late 80s, early 90s. She kisses me. The Oedipus complex because it mates with its mother. And my favorite, the piece of cake. And this one was named because it was a beetle that smashed into their windshield. Nobody had ever seen it before, and they're like, we just named a species. Piece of cake. So there we go. That's taxonomy. Those are the basic rules for how you name organisms and how you can sort them.